Assalamualaikum Honorable Panel, Dr. Buhairi and Dr. Rusti. Hope both of you is in a good health. Here I'm going to present my final year project with the title of Modular Robot Convoy in the straight pipe and bend pipe. Before I go further, let me introduce myself. My name is Muhammad Shazwan bin Muhammad Zamiri and my supervisor for this project is Muhammad Zamzuri bin Abdul Rashid. Pipeline is utilized as a major tool for many countries to construct important lifelines such as water and gas supply in our society. Besides that, pipeline facing problems such as aging, corrosion, physical damage from the third parties, and defect in the pipeline recently. Maintenance are strongly demanded by huge budget. Large amount of time, effort, and work is necessary if the inspection is carried out manually by group up the pipe that are buried in the ground. In contrast, low cost is needed if the robot can inspect inside the pipe fast and accurate for the maintenance of the pipeline. Last but not least, usage of the robot can also decrease risk of injury to operator as the inspection can be done distant away from the complex internal and hazard content of pipes. As we knowledge that robotic is an automatically operated machine that replaces human effort. That replace human effort. So it may not resemble human being in the appearance or perform function in the human-like manner. By extension, robotic is the engineering discipline dealing with the design, construction, and operation of robot. There are many types of robot in the world. One of them is modular robot. A modular robot is a self-reconfiguring robotic system or self-reconfigurable modular robot are autonomous kinematic machine with variable morphology. By saying self-reconfiguring or self-reconfigurable, it means that the mechanism of device is capable of utilizing its own system of control such as with actuator or stochastic means to change its overall structural shape. While for inspection of such pipe, robot requirement is must, especially in order to check corrosion level of pipe, recovery of usable part for pipe interior, for the sampling of sludge and scales formation on pipe internal surface. Design in a new pipe inspection robot is carried out in this research work. Motion simulation and experimental study are performed with the help of the solid model and an initial robot. Robotic convoy is consists of the lead vehicle and the following vehicle. So here I want to design the combination of modular robot convoy which implement in the straight pipe and bend pipe. The problem involved when there is a lack of modular robot convoy for the straight pipe and bend pipe inspection. The existing robot face problem stuck when it is moved to bulky as and long distance in pipe. Current solutions are bulky in size 355.6 mm and are not appropriate to be utilized in the small size 152 mm pipe. While the objective that I want to achieve are firstly to design and fabricate a modular in-pipe robotic system to move inside the straight pipe and bend pipe. Secondly, to test and analyze the behavior of the modular in-pipe robotic convoy to ensure follower can track the leader with a certain distance. Lastly, to test and analyze the behavior of the modular robot in-pipe during locking mode. The scope of the project is only focused on the wall press in pipe articulate robot with variable diameter ranging from 120 mm until 160 mm, which can press a straight pipe with inner diameter of 150 mm. For controller board is utilizing by Arduino microcontroller to control the movement of the robot, while the robot is equipped with 4 active wheels with diameter of 55 mm actuated by 4 DC gate motor and has 8 passive wheels. I am using ultrasonic sensor for robot movement by using wall press type. According to the study and the result, there are many kinds of research I found. Some of the concept and process are taken to do this project. This is the summary of my literature review. Robotic technology is one of the most increasing engineering sector. Three main robots that involved are in a pipe robot, robotic convoy, and modular robot for the improvement of safety and efficiency in the industrial plant. Pipe inspection can be important. By Ankit Nayak 2015. They are classified by with the important history behind it is possible to classify the creation of in-pipe robot in robotic into their application with three different subgroups. In wheel type robot, wheels are directly connected to motor to get desired locomotion. They have simple structure and better velocity control with small car-like structure, while in wall press robot, the wheels are mounted on the elastic arm, which provide adaptability and required frictional force to the robot. Screw type robot have two modules, a stator and the rotor. Without wheels type robot can be classified in three categories. First, inchworm type robot, which have inchworm type motion in pipeline with the help of two clamping and one elastic module. Snake type robot have number of articulate active module, and leg type robot is able to climb vertical and horizontal pipeline having L, T, and Y joint. Caterpillar type robot has two categories, Caterpillar robot simple structure and Caterpillar robot wall press type structure. Comparison is different between in the pipe inspection robot on the basis of different performance indicator have been done to find the suitable motion mechanism of the robot for same working condition. The comparison is shown in the table. On the basis of table, it can be concluded that the wheels type mechanism wall press type is better choice as compared to other. So, the wheel type mechanism wall press type has been chosen to develop modular robot convoy. The Gantt chart shows the progress of the project. This is the overview flowchart of the system operate. Firstly, press the start button. The motor will drive forward as be programmed at the Arduino. It will be collect information from ultrasonic sensor that measure bending pipe distance by emitting the ultrasonic sounds wave and convert the reflex sounds into the electrical signal. The obstacle detection will happen by sending information from the ultrasonic sensor to modular robot convoy. There are two multiple paths for robot convoy, either in the straight pipe and bend pipe. For the bend pipe, the grip of the gripper on the leader will dissipate from the follower. Of the follower will move behind the leader until the ultrasonic sensor provide information that there is no bend path is identified. While the straight pipe, the leader and follower of modular robot convoy will operate together. The robot journey will depend entirely on the condition of the road pipe. For component selection, I'm choosing Arduino DC gate motor, ultrasonic sensor HCSR04 and servo motor SG90. Function of Arduino is to run the other three components: DC motor, servo motor and ultrasonic sensor. DC gear motor. For DC gear motor, the spanning is between 3 volt until 7.5 volt. 80 RPM with the gear rotation of 120:1 and the torque ability is 257 kg per cm. For ultrasonic sensor HCSR04, the effectual angle is 15 degrees. Ranging system is 2 cm until 400 cm. Resolution is 0.3 cm. Measuring angle 30 degree. Trigger input pulse with 10 microsecond, and the dimension is 45 mm times 20 mm times 15 mm. Servo motor SG90, speed at 4.80 volt, 0.2 second per 60 degree, torque at 4.80 volt, 1.8 kilogram per centimeter, rotation angle 180 degree, and size is 23 mm times 12.2 mm times 29 mm. The mathematic modeling used are for allowable length and width. I have two preliminary results which I managed to get. It is by the calculation software and robot design. First is the MATLAB coding for the length of vehicle unit and nominal diameter of pipe. DV stand for diameter of vehicle unit, R stand for radius of curvature of bend, alpha equal turning angle in bend, dp stand for nominal diameter of pipe, and length stand for length of vehicle unit. This is the calculation result that generated by MATLAB software. So the diameter of pipe that I choose is 152 mm, while the length of vehicle is 222 mm. For robot design, I'm using Fusion 360 to create the modular robot convoy. This is isometric view for the modular robot convoy. In this modular robot that I had designed, that involves such as absorber, gripper, hook, DC motor, and tire. In conclusion, design and fabricate a modular in-pipe robotic system to move inside the straight pipe and bend pipe using Fusion 360. Had test and analyzed the behavior of the modular in-pipe robotic convoy to ensure follower can track the leader with certain distance by using ultrasonic sensor. Test and analyze the behavior of the modular in-pipe robot during locking mode was generated by program used in Arduino. This too is the main reference that I use in this project. That's all from me. If you have any question, you can contact me by the info given. Thank you.